All right. Okay. So molal boiling point constant for water is 0.513 per degree, degree kilogram per mole. This we know, right? So your Kb is given. That's called molal boiling point constant or ebullioscopic constant, and that's given as 0.1513 degrees Celsius. When 0.1 mole of sugar, right? So number of moles is 0.1 mole, is dissolved in 200 grams of water. So the mass of solvent, weight of solvent is 200 gram, right? So at what temperature does the solution boil, right? You know, normally what is the boiling point of water, students? Yes, Evelyn?
Sir, 373 Kelvin or
Or
100
Evelyn,
degrees
given in degree
Celsius.
Celsius, so 100 degrees Celsius, correct?
Yes, sir.
Yes, so it's going to be 100 degrees Celsius is the normal temperature at which it will boil. Right? Now, the elevation in boiling point is given by the molal elevation boiling point constant multiplied by molality, correct? So that's what we need to find. So what is the ebullioscopic constant? It is 0.513. We need to find the molality. What is molality? We have number of moles, which is 0.1 divided by weight of the solvent is given in grams, right? 200. If it is given in grams, then you need to multiply it by 1000, right? Because per kg of the solvent. So this will give you molality. So what are we getting here? 0.1 into 100 is what? Sorry, 0.1 into 1000 is 100. 100 by 200 is 1 by 2. 0.513 divided by 2. So that will be what? So 0.256 degrees Celsius, correct? So that is a change or that is the elevation in boiling point. So your water is not going to now boil at 100 degrees Celsius. The solution is now going to boil at 0.256 degrees Celsius extra. So what is the right answer? What is the right answer? 100 plus 0.256. So what is the answer? 100.256 degree Celsius. Is it clear? Yes, Evelyn, could you explain this once more to everybody? Unmute yourself. Are you there, Evelyn? Okay, Ranika, can you unmute and explain?
Yes, sir, I'm there. I didn't know you were talking to me, sir.
Yes, yes, yes. Just unmute and explain the whole thing.
Sir, here we the molar boiling point constant is given, sir, for water, which is 0.513, and now they are saying that when 0.1 mole of sugar is dissolved in 200 grams of water, the solution boils under a pressure of 1 atm at. So here we have to find the boiling point of the solution. So here the number of moles of the solute is 0.1, and mass of the solvent is 200 grams. So to calculate the what boiling point of the solution, we have to find delta TB, which is given by Kb into m, where m is the molality. So after substituting the formulas, we get delta TB as 0.256 degrees Celsius, and the boiling point of the solution is delta TB plus the boiling point of water, which is 100 degrees Celsius. When we add them, we get 100.256 degrees Celsius.
Correct, correct. Is it understood, Ranika? Did you get it?
Yes, sir.
Yeah, Jerome?
Sir, one doubt, sir.
Yeah.
When do we add the boiling point of water, sir?
See, in the last step, here, elevation, right? So this is the temperature at which the solution boils. The temperature at which your pure solvent boils. This difference is called delta TB. So if you want to find T of solution, the boiling point of solution, right? Then you have to take this side, right? Yes, Jerome?
Yes, sir.
So delta TB plus the temperature of the boiling point of pure solvent. Is it clear now?
Yes, sir.
That's the reason in the last step you are going to add them. So 0.256 plus 100. Is it clear now?
Yes, sir.
Yeah. Okay. Good. So let's go to the next question now. Okay. Yes. Enoch, can you unmute now?
Yes.
Yeah. So an aqueous solution containing 1 gram of urea. See, one more thing you guys can observe is in both these questions, if you see, right? Earlier we discussed sugar, we discussed glucose, right? I'm sorry, 0.1 mole of sugar, right? Which is sucrose. And now we are talking about urea. All these are organic compounds and these do not dissociate, correct? They do not dissociate into ions, correct? So that's why we have not, there was no need for us to talk about abnormal colligative properties in these compounds. But the moment we look at some of the other compounds, right, which are, let's say, especially inorganic compounds like sodium chloride, etc., then we will need to talk about abnormal colligative properties. Okay, we'll come to that. Anyways, next or the subsequent questions, we'll have it. Okay. So we will just discuss it when it comes. Fine. So now, you can stay on mute. So aqueous solution containing 1 gram of urea. So what is the mass of the solute? Enoch? Solute is urea. So what is the mass?
1 gram.
1 gram, right? Okay. And what temperature does it boil the solution?
100.2
Yes,
Celsius.
right. So solution is given. So temperature, the boiling point of the solution is given. That is given as 100.25 degrees Celsius. Now the question is, if the mass is not 1 gram, but if it is 3 grams of urea that I'm taking, there are not 3 grams of urea,
Glucose.
3 grams of glucose that I'm taking in the same volume. 1 gram of urea, this is 3 grams of glucose. Now what will be the boiling point of the solution? Let's say this is the boiling point of the solution 1. Now I want to find the boiling point of the solution 2. Volume remains same. Okay. Fine. So question is open to everybody. Can you guys tell me? So what is the first step? What is the formula for elevation in boiling point? Kb into molality, right? Correct. So now Kb is going to be same for both in both cases. Only chance is that molality may be different. If molality is different, they will boil at different temperatures. Correct? So, Enoch, tell me what is the formula for molality?
Number of moles by mass of solution in kg.
Not solution, Enoch. Mass of solvent.
Solute in kgs.
Not solute, solvent.
So
Given mass of the solute. What is the given mass of the solute in the first case?
1 gram.
1 gram, right? Number of moles you need to find. So urea, what is the molecular mass, Enoch? You said it earlier.
The 60, sir. Sorry.
Correct. What is urea?
60.
This is urea. Okay. So you can see that nitrogen, 2 atoms of nitrogen are there. So 28, 4 atoms of hydrogen are there, 4. 1 carbon is there, 12. 1 oxygen is there, 16. So it is 60. So molecular mass is 60, right? So given mass divided by molecular mass, that is your number of moles, divided by volume of the solution, not volume, I'm sorry, mass of the solvent, right?
And TB is equal to 100.25. And it will remain
So
the
let's
same.
take
Sir.
mass of
So
solvent to be M solvent, same, okay. So you can see that the molality is only now depending on the number of moles, that's all, right? So it is 1 by 60 in the first case.
Sir,
Yes, everyone.
sir, here there's 1 gram of urea present, right? So can't we take the mass of solvent as 99, sir?
Mass of solvent can be, see, you don't know, it is a 100 gram solution, right? It is not percentage thing, right?
Yes, sir.
So you wouldn't be able to say that it is 100 gram. Got it, Evelyn? Yeah, okay.
Yes, sir.
Now, let's do the delta TB for the next solution, no? So the only place where it can change is the molality. Yes. Now, come on.
so KB into 3
Maybe it's
by
going to say remain
180.
same.
Yes, sir.
So only thing is
So-
number of how many grams of glucose?
3 grams
What is the molecular
by
mass of
180.
glucose?
180.
Good, very good, very good. Because and what is the molecular formula for glucose? What you remember the answer without knowing the formula, no? C6H12O6, okay. 6 into 12, 72. 12 into 1, 12. 6 into 16, 96. So 9 plus 9, 18, 180. Got it? Okay. So 3 divided by 180 divided by mass of the solvent. So if you see the number of moles in both the cases, right? What are you going to get?
1 by 60.
Therefore, the rest of the quantities remaining constant. Your delta TB in both cases will be same. Correct? Therefore, the new solution of glucose will also boil at the same temperature as urea. So what is the right answer? D. 100.25 degrees Celsius. Is it clear, students?
Sir, can you explain this again?
Yeah, sure. An aqueous solution containing 1 gram of urea boils at 100.25 degrees Celsius, right? The aqueous solution, right? Same solvent. Containing now 3 grams of glucose in the same volume will boil at. Right, Evelyn? So now if you see, your formula is Kb into molality, right?
Yes, sir.
If the elevation and boiling point is same, then both the liquids are going to boil at the same temperature, right?
Yes, sir.
So we are just looking at what happens to the elevation and boiling point, and we see that Kb and mass of the solvent are same in both cases. Only difference is the number of moles, right? Possible difference.
Yes, sir.
So in the first case, it's urea, right? 1 gram. Number of moles is what? Mass by molecular mass, so 1 by 60. In the second case, it is glucose, number of moles of glucose. 3 grams in 180, 3 grams, right? So 3 divided by
Yes.
180, right? So 3 divided by 180 is same as 1 by 60.
Yes, sir.
Therefore, in both cases, delta TB is same.
Yes, sir.
Hence, both the solutions will boil at the same temperature.
Yes, sir.
Any doubts, Evelyn?
Sir, I just have one question, sir.
Yes.
Sir, here it's mentioned as same volume, sir.
Yes.
They didn't tell that mass of the solvent is same, right?
Correct. Correct. So there is an approximation. So ideally, as you rightly said, mass of the solvent must be given as same. Okay. But same volume here, you can one assumption we may have to make, like suppose if the solvent is water,
Yes, sir.
then it's 1 gram is equal to 1 ml.
Yes, sir.
So even in such case, there might be a slight discrepancy because if you are having 1 gram, let's say in 1,000 grams of water. No. If it's same volume of water solvent, then it is fine. So there is one, as you rightly said, this is slightly misleading.
Yes, sir.
Yeah. Good point. But right now in this question, you take it as same mass of the solvent. Even if you want, you can correct it to same mass of the solvent. Because the moment they say same volume, then you need density. Ideally speaking, we need density information also
Yes,
to
sir.
get the mass of the solvent. Okay, perfect. Very good. So take it as same mass of the solvent. Okay. Shall we move on, Evelyn? And others?
Yes, sir.
Yeah. Okay. Now let's try this. Solution of sucrose. Molecular mass is already given. Even if it's not given, you should be able to know this, right? So solution of sucrose, molecular mass 342 is prepared by dissolving 34.2 gram of it in 1,000 gram of water. Very clearly given, right? Now, what will be the freezing point of the solution? Very simple question. Yes, Jerome, come on. What happens to the freezing point when you add a solute to the solvent? We saw.
Sir, it
Ah,
increases, sir.
see, Arma, elevation in boiling point. Boiling point will increase when you add solute to pure solvent.
It decreases, sir.
Depression in freezing point, correct?
Yes.
The freezing point will decrease because the process is different, right? You're trying to get the molecules closer, right? In case of freezing. So freezing now will become more challenging with solute particles. So it'll freeze at a lower temperature than it was. So there is a depression in freezing point.
Sir,
Yes, Evelyn.
sir, can you just explain this point again, sir?
Sure, Evelyn. See here, uh, boiling point is the temperature at which your vapor pressure becomes equal to the atmospheric pressure, right?
Yes, sir.
Now, when there are solute particles, correct? When solute particles are going
Yes.
to be present, right? Then what will happen? The solvent molecules will start interacting with the solute particles. Not all of them will have the tendency to go to the vapor state, correct?
Yes, sir.
So vapor pressure of the pure solvent was more than now when the solute is also added, correct? At the same temperature, correct? So now if you want to produce the same amount of vapor pressure of the solvent, then what you should do? Boil it more, right? So it is not getting, the boiling point is not now 100 degrees Celsius. It is now 100, more than 100, right? For what? For a water
Yes, sir.
solution, correct? Okay. Now on the other hand, right? Freezing. What is freezing? Freezing is a process, right? So let's say you're converting a particular solvent in liquid state to solvent in solid state, correct? So what is going to happen? There is a process where molecules have to interact differently and they have to come closer, correct or not?
Yes, sir.
Yes. So now this process happens at a lower temperature, correct? Yes or no?
Yes, sir.
Yes. Compared to 10 degrees Celsius, let's say at 8 degrees Celsius, molecules are still closer, correct? Now this process happens. Now, if this process has to happen better, then you have to still reduce the temperature, correct? Yes. Now, at 0 degrees Celsius, it's converting from liquid phase to solid phase, correct? In case of water or any other substance which is going to freeze, correct? Now, when solute particles are going to be present, is this process of freezing going to be hindered or not? Hindered, right? Correct or not? So now,
Yes.
yeah, if you want to achieve the same level of, a conversion into a solid, now do you need to put more effort or less effort?
More efforts.
More effort in the sense, is it a cooling process or a heating process?
Pulling, sir.
Yes, that means you have to decrease the temperature further or increase the temperature.
Decrease, sir.
Yes, that's the reason there is a depression in freezing point. Is that clear now?
Sir, so molecules come together when there is a decrease in temperature.
Yes, right. Because your heating causes expansion,
Yes, sir.
cooling causes compression. Your basic laws
Contraction.
of thermodynamics, right?
Yes.
Concept in thermodynamics, correct? Evelyn? Yes. In summers, you can see, right? Your wooden doors sometimes get stuck because they extend, they expand. All right. So there is a depression in freezing point. Yeah, got it, Jerome?
Yes, sir. Got it.
Freezing point will decrease when you add solute particles to the pure solvent. So, if the temperature at which normally the solvent freezes is T degrees Celsius, the temperature at which the solution will freeze now is less than this temperature or more than this temperature?
Less, sir.
Less, correct? Yeah. So this is temperature at which your pure solvent will freeze, and T is the temperature at which the pure solution will freeze. And obviously, the solvent is going to freeze at a higher temperature. So higher value minus lower value will be your depression in freezing point, or I can say delta TF. And that delta TF will be nothing but cryoscopic constant or molal depression freezing point constant, AF, into molality. The treatment is very similar to how we treat in case of elevation in boiling point, right? So very, very simple to understand. So as you can see, all that we need to calculate is molality now. right? So depression in freezing point will be nothing but cryoscopic constant, and that's given as 1.86. We need to find molality. And what is molality? Number of moles of the solute divided by mass of the solvent in kg. So that is nothing but 1.86 multiplied by what is the number of moles? Weight of the solute by molecular mass. Weight of the solute is 34.2 gram. That you need to divide by molecular mass. Molecular mass is 342 for sucrose. And what is the mass of solvent? 1 kg. So it is given 1000 grams, which is 1 kg. So very simple to calculate, no need for calculator. 34.2 divided by 342 is what? 1 upon 10. So 1.86 gets divided by 10. So you get 0.186 degrees Celsius. Got it? So this is the depression in freezing point. So now come to this formula. So you want to find the temperature at which your solution freezes. So bring T solution this side. Take delta T of the other side. So temperature at which your solution is going to freeze is going to be equal to temperature at which the solvent is freezing minus the depression in freezing point. So your solvent is going to freeze at 273 Kelvin. Am I right? Or 0 degrees Celsius, correct? 273.15. So that's fine. 273 we can take it, no problem. You'll subtract 0.186 now from this. So your solution freezes at 272.814 Kelvin. Or you can simply say minus 0.186 degrees Celsius. So the right answer is the first option. Is it clear, Jerome?
Yes, sir.
Anika?
Yes, sir.
Sai Kiran, Evelyn?
Yes, sir.
Yes, sir.
Yes, ma'am. Very good. If you have taken down, we'll move on to the next question. Have you all taken this down? Jerome, completed?
Yes, sir.
Okay, good. So now we'll move on to the 35th question. Okay. An aqueous solution of a weak monobasic acid containing 0.1 gram in 21.7 gram of water freezes at 272.817 Kelvin. If the value of Kf is 1.86 Kelvin kilogram per mole, the molecular mass of the acid is. Please calculate yourself, everybody. All data is given. S0, what is delta TF? What is depression in freezing point?
KF into molality, sir.
Very good now. Depression in freezing point, will you be able to identify with this information? What is the normal temperature at which, what is the temperature at which your water freezes?
273, sir.
Now what is it freezing at?
272.
Not 272, 272 point.
Point 817.
So the difference will be depression in freezing point, correct or not?
Yes, sir.
So what is the difference? .183, correct?
Yes, sir.
So this is 0.183 and your KF is 1.86, correct? Approximately, suppose if I take this as 6, right? This, how many times would it be? 10 times, correct? Into molality, we have to calculate now. What is molality? What is molality, Jerome?
So number of moles of solid divided by mass of solvent in kg, sir.
Correct. So what is number formula for number of moles?
Given weight divided by molecular mass, sir.
Yeah, what is the given weight here?
0.1 grams, sir.
Yes, 0.1. And molecular mass, we don't know, right, Jerome? So 0.1 divided by molecular mass, which we don't know. Let's keep it like this. Divided by mass of the solvent is given. How much is the mass of the solvent?
21.7 grams, sir.
Yeah, 21.7 gram, right? Gram means you convert into kilogram divided by 1000, correct? Yes, Jero?
Yes, sir.
Yes. And you can see this 10 and 0.1 will cancel, correct?
Yes, sir.
So you can bring the molecular mass this side, M this side. So it will be basically 1000 divided by approximately 1000 divided by 21.7. I'll make one approximation here. Suppose 21.7, I make it as 20 only. All right, then it will be what? What is 1000 by 20?
50, sir.
50, right? So your answer will be approximately 50, but less than 50 because denominator is more than 20. So which answer is correct?
46.8.
Yes, 46.8 will be correct answer. Did you understand?
Yes, sir.
That's all. Yes, Ranika, Evelyn, others who are there on the call.
Yes, sir.
Okay.
Sir, can you explain this simplification part again, sir?
Sure, Evelyn. See, because especially in the competitive examination, because you don't have the calci, you have to do it, faster, smartly and quickly, right? So that's why what I did, first approximation I did is, I'm getting 0.183, right, Evelyn? I made it
Yes, sir.
0.186. It doesn't make much difference. Why did I make it 0.186? Because KF for water is what?
1.86.
Yeah, so it becomes 10 times, right, Evelyn? That's the first
Yes.
calculation approximation I did. Is it okay? The next is
Yes.
weight is 0.1 gram divided by molecular mass. That's fine. 21.7 gram of water, right? So gram, so I multiplied by 1000 here. That's clear, right?
Yes, sir.
This 10 and 0.1 cancel, right? They become 1. And this molecular mass, you take it to the other side. So M will be equal to, basically we are left with 1000 by 21.7, correct? Approximately.
Yes, sir.
But I don't want to do that calculation also. So what did I do? I just made the 21.7 as 20. So what is 1000 by 20, Evelyn?
50, sir.
But my denominator is not 20, it is 21.7, which means it's more than 20, right? Because
Yes, sir.
denominator is slightly more than 20, your answer will be slightly less than 50.
Yes, sir.
So we boil down to this answer.
Okay, sir.
Clear, Evelyn?
Yes, sir.
Yes, very good. So we'll move on to the next one. So, which is the question number next? 36.
36, sir.
All right. What is the molality? What is the molality of a solution of certain solute in a solvent if there is a freezing point depression of 0.184 and freezing point constant is 18.4? So we know that delta TF is equal to KF into molality. Here what is given? Freezing point depression is given, which means delta TF is given, that is 0.184 degrees Celsius or Kelvin. Freezing point constant is 18.4. We need to find what is molality. Very simple question. So molality is nothing but 0.184 divided by 18.4. So you can clearly see that the denominator is 100 times of the numerator. So answer is 0.01 molal. So first option is correct. Clear? Okay, let's move on. Okay. A solution containing 6.8 gram of a non-ionic solute in 100 gram of water was found to freeze at minus 0.93 degrees Celsius. The freezing point depression constant for water we know is 1.86. Calculate the molecular mass of the solute. This is also simple. So normally it boils at freezes at 0 degrees Celsius. Now it is boiling at minus 0.93 degrees Celsius. Therefore, the depression in freezing point we know is Kf into molality, and this depression is 0.93. And your Kf is 1.86. And molality, yes.
Sir, here it is said that the solution is found to freeze at 0.93, sir.
Minus 0.93, correct?
Yeah, so it's not delta TF, no, sir.
No.
It's the freezing point of the solution.
Correct, Evelyn. What is delta TF? Tell me, Evelyn. It's the temperature at which your water freezes, right?
Yes, sir.
Minus the temperature at which your solution freezes, right?
Yes, sir.
What is the temperature at which water freezes?
0 degrees Celsius.
What is the temperature at which your solution is freezing?
Oh, okay, sir.
Clear, Evelyn?
Yes, sir.
So now it becomes 0.93. I just wrote it directly. Okay, molality. Molality is nothing but number of, given weight, 6.8 divided by molecular mass. We don't know what it is. And divided by 100 gram of water. So 100 gram, what I should do? Multiply it with 1000, right? 10, right? Okay. So now you can see 0.93, 2 times is 1.86, correct? So molecular mass, if you bring the M this side, M will be equal to 2 into 6.8 into 10. 6.8 into 10 is 60, 68, sorry, 68. 68 into 2 will be 136. Therefore, the molecular mass of the solute is 136, which is the fourth option. Is it clear? Any doubts now? Any doubts, Jerome, Evelyn, Ranika,
No, sir.
Aditya?
Yes.
Accurate?
No, sir.
Okay. Shall we move to the next question? I hope all of you are getting this. Okay. Next question, 38. Okay. Molar freezing point constant for water is 1.86. And molar mass for sucrose, is 342. The given weight is also 342 grams, which means you have 1 mole. And the mass of the solvent is also 1000 gram, or you can say 1 kg. Yes, all these numbers are very simple to work with, right? Now, what temperature will the liquid freeze? So we know the delta TF is equal to KF into molality. KF we know is 1.86, and molality is given weight, which is 342, divided by molecular mass, that's also 342, divided by the mass of the solvent is 1 kg. So you can clearly see that delta TF is 1.86 degrees Celsius. So your solution, instead of freezing at 0 degrees Celsius, will now freeze at minus 1.86 degree Celsius, correct? Because the freezing of your solution will be nothing but freezing point of your solvent minus delta TF. The freezing point of the solvent is water. So 0 degrees Celsius minus 1.86. So you get minus 1.86 degree Celsius, which is the first option. Clear?
Yes, sir.
Very good. Okay, so we'll do the next question. Okay, Evelyn, can you try this question and get me the answer? Everybody, please try it.
Yes, sir.
Please make it as 0.1 molal solution. Small m, usually we use small m for molal.
Sir, third option, sir.
Very good, Evelyn. Is it third option?
Yes, sir.
Yeah, perfect. What is an expected wrong answer, Evelyn?
Um, I don't know about the expected answer because I didn't solve it.
Okay. How did you get 0.37?
No, okay. It is 0.186 minus 0.186.
Is what?
What, sir?
No. What is your answer? Is second option or third option?
No, I'm telling the wrong option, sir. You told expected one, so it's the
Yes.
second one.
So I was
Third
expecting.
one.
I was expecting you guys to give the second option. Okay, so second option was the expected wrong answer, but you guys are very smart. So you gave the right answer. So what is the right answer, Evelyn?
Minus 0.372 degrees Celsius.
Yes, very good. Ranika, are you getting minus 1.186?
Yes, sir.
Very good, Ranika. Yes, Jerome, are you getting minus 0.186?
Yes, sir.
Very good. Okay. So that is an expected wrong answer. Okay. So if you just apply the formula, what we have done so far, you will no doubt get minus 1.186 because your delta TF is equal to KF into molality, correct? So KF is 1.86 and molality is 0.1. So what do you expect? 0.186, correct? So normally the water will freeze at 0 degrees Celsius. Now it will be 0 minus 0.186. So answer should be minus 0.186. Am I right? Not boil, freeze. So a solution should freeze at minus 0.186. Correct now? Yes, Ranika?
Yes, sir.
Correct. Okay, but why is it wrong answer? Because we have not considered a factor called Van Hoff's factor in this question. Why specifically in this question, sir? All questions we have solved, we didn't seem to consider Van Hoff's factor at all so far. But if you observe all those compounds were like, organic compounds or non-ionic, right? Urea, glucose, sucrose, all these. They don't dissociate in solution, correct? Whereas now we are talking about sodium chloride. We have to pay attention to that. Sodium chloride in its solution, aqueous solution, will split as we had discussed this part briefly when we discussed lowering of vapor pressure, right? So it splits as sodium plus M, Cl minus. So what happens, students? Instead of you expecting colligative property of one molecule of sodium, one particle, you will see that of two particles. Hence, Van Hoff's factor I for sodium chloride is 2 because one molecule splits into two ions. So this whole thing you have to multiply by 2. So you got it now, Ranika?
Yes, sir.
So the answer is not minus 0.186, it is minus 0.372. Is it clear, Jerome?
Yes, sir.
Okay, excellent. Okay, so with that, we will conclude today's session. We'll be continuing with the same paper in the next class in chemistry. Or probably after our test tomorrow, we shall discuss the remaining part of the paper when we meet. Okay. All the best, students. Take care. Hope you understood. Good night.